Bismillahirrahmanirrahim. Good morning, distinguished guests and colleagues. My name is Sifa Ulhaq Nadila, and it is an honor to present our research on comparative analysis of flexural strengthening for reinforced concrete beam using single and double lines of FRP plates. This study was conducted under the supervision of Dr. Arya Wangunadi MT at Bandung State Polytechnic. I will begin by introduction, the objective and background of our research. The first introductions, fiber-reinforced polymer or FRP has become a crucial material in enhancing the performance and durability of civil infrastructure. There are various types of FRP fiber, including aramide FRP, glass GFRP, bamboo BFRP, carbon CFRP, and natural fiber and FRP. Each offering different degrees of resistance depending on environmental factor. FRP reinforcement has shown to increase flexural capacity by 20 to 100% based on the type of fiber used and the condition of the concrete substrate. However, despite its advance, challenges remain particularly with carbon fiber reinforced polymers (FRP), where used such as the plate and debonding and mine flexural crack limits its effectiveness. This challenge from the focus of our research as we aim to optimize attachment technique and improvement the long-term durability of FRP reinforced structure. Previous studies have consistently demonstrated the mechanical benefit of using FRP material to strengthen concrete structure. However, specific challenges, especially with FRP, such as the bonding at the plate ends and mild flexural cracking, often hinder its full potential. To mistake these issues, advanced methods like near surface method (NMS) and externally bound reinforced ABR technique have been investigated. The literature underscored the need for improving bonding technique and refining installation method to ensure the long-term effectiveness of FRP in civil engineering applications. This study, we conducted tests on 3 reinforced concrete beam specimens. The first, a control beam or CB, a single line FRP beam, FP1 line, and a double line FRP beam, FP2 line. Each beam had dimension of 250 mm by 300 mm by 3000 mm and was subject to a monotonic 2-point loading test. The FP1 line specimen was reinforced with a single layer of CFRP, while FP2 line employed double layer configurations. Our focus was on evaluating the first crack load, maximum load capacity, deflection, and ductility, and less following the guideline of SNI 4431:2011. Finding and discussion, the result of our study as follows. The FB1 line beam exhibit a 40.85% increase in the first crack load compared to the control specimen or CB. However, it's also demonstrated an 11.42% reduction in maximum load capacity. In contrast, the FB2 line beam show a substantial improvement with a 126.05% increase in force crack load and a 10.90% rise in maximum load capacity. And nevertheless, it experienced a significant reduction in ductility by approximately 52.01%. In terms of failure modes, we observed addition failure and delaminations in the FB1 line specimen, while the FB2 line beam perform better in load capacity, but at the cost of reduced ductility. This finding highlight the importance of proper surface preparations, enhance bonding, and reduce the risk of the bonding in FRP reinforced structure. At last, in conclusions, our study found that double line FRP reinforced FB2 line provides superior load-bearing capacity compared to single line reinforced FB1 line. However, its use of debonding, particularly with the single layer reinforcement, remains a significant challenge. Our results suggest that optimizing surface preparation technique and layering of FRP can mitigate these risks, ultimately enhance the structural performance and durability of FRP reinforced beam. Future research shall be focused on refining this application technique to address this challenge effectively. These are primary references that have support our research, including recent study on the mechanical properties of FRP composite, flexural strengthening using various fiber types, and the application of FRP civil infrastructure. This work have contributed significantly to the foundation of our study. Thank you for your time and attention. I will now be happy to address any question or engage in future discussion on this topic.